All right, homework answers from last night. I think this is it. Yes, it is. Okay, ready? The first question I want to talk about is the first question on the last page. And what it asks you to do is to find the length of the distance between -1, 4, which is here, and 2, 0, which is here. So they want you to find the length of this line. And what I do is I turn it into a right triangle, because in a right triangle, I can use, Ishii, if you get the book, please, I can use the Pythagorean theorem, namely leg squared plus leg squared is hypotenuse squared. So this leg is 3 and this leg is 4, and I do 3 squared plus 4 squared is h squared, and that makes 9 plus 16, 3 squared and 4 squared, is h squared. H squared is 25, do the square root, and I come up with 5. Are there any questions on that? Okay. The next one they ask about is the slope. Take the same 2 points. Here they are. I labeled them point 1 and point 2. And it's the y from the second minus the y from the first, or the x from the second minus the x from the first. Plugging in the numbers, I come out with -4/3. Is there any question about that? Now, that's actually a very good question because it combines review with kind of what we're doing currently. So it's a good thing. Stephen, head in the game. Now, the next thing we want to do is talk about the last question, which is really what we've been doing lately. Now, when I first started doing this question, I thought it was a triangle. Then I realized it was a rectangle. So here's A, B, C, D, the red rectangle. And the first thing they ask us to do is to reflect it over the y-axis. So remember, what are the 3 words you always use when you reflect? Count and repeat. Good. 1, 2, 1, 2. 1, 2, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4, 1, 2, 3, 4. And then it says write the coordinates, which I did. I wrote the coordinates right here. Okay? And then after that transformation was done, it asked me to dilate. What is the thing you need to remember about dilating? What operation do you always use when you dilate? Multiplication. So I take 2, 1, I multiply and I get 4, 2. I take 4, 1, I multiply and I get, oh, that should be 8, 2. It looks like it's at 9, 2. Sorry for that, I did it very quickly. This should be 8, 8, and then 4, 8. And that would be what your picture looks like. Now, the last thing to do is to write the rules in terms of what's happening. And if you noticed, when we did the reflection, the x guy stayed the same, but the y guy, the x guy got negated, but the y guy stayed the same. Whatever axis you reflect over will always stay the same. So I get -xy. And for the dilation, I multiplied by 2. So xy becomes 2x, 2y. Because 2x means 2 times x, and 2y means 2 times y. All right? Are the perimeters and areas of the first 2 the same? Yes, they are. Are the perimeters and areas of the last one and the first one the same? No, they are not. Because the dilation changes the size. Okay? Any questions about those homework questions? Chris? Did I ever tell you how much I hate when kids get up out of their seat during class? Because you know what happens when you do that? Every kid loses their attention. So next time, wait till the end of the period. Okay. Now, let's go through the questions that we have here. What's the image under a dilation? What operation did we just say we use for a dilation? Rich? Multiply. So the scale factor is -3, so I'm going to multiply both of those by -3. What's 3 times -3? Hey, -9, good. And what is -4 times -3? 12. So I get -9, 12. Next, what's the image of -2, 4 after a reflection in the x-axis and then the y-axis? You could remember that when you reflect over the x-axis, the x stays the same, and that would give you -2, -4. But most kids don't remember it best that way. Most kids remember it best, Rach. Most kids remember it best this way. Let's go to -2, 4. Here it is. Now let's actually do the reflection in the x-axis. 1, 2, 3, 4. 1, 2, 3, 4. There's my image point. What are those coordinates? -2, -4. Then it says, what if I would have taken this original point over the y-axis? 1, 2, 1, 2. That would become positive 2. Okay? Any questions? And as far as graphing the line on there goes, 1/4 x plus 3, I begin at 3, I go up 1 over 4, up 1 over 4. All right, here's my first triangle in blue. And remember, similar means same shape, different size. Here's my triangle in green. This has a length of 4. The whole thing has a length of 8. This has a length of 1. The whole thing here has a length of 2. So clearly, because I went 2 slopes, the thing got twice as big. The triangle got twice as big. Okay, any question about that? That's a scale factor of 2. All right, so if you can handle those kind of questions, that means you have a pretty good grasp on what we've been talking about so far. Today, well, first off, there are 4 different types of transformations we need to learn about in this chapter. The first one, done, dilations. The second one, done, reflections. Now, I say done, but you've been in class long enough to know that every day I'm going to ask you about dilations. Every day I'm going to ask you about reflections. Because I don't do this one and done stuff, where we cover it for a day and then we're done covering it. We cover it, and then every day we hit it a little bit more, and a little bit more, and a little bit more, to get a little deeper, and to solidify how we can work with these problems. Today we begin the third type of transformation, rotations. And tomorrow we begin the last type of translations. And then, after 2 days of translations, which would be Friday, Monday, on Tuesday, we begin to spend, I think, 3 days where we kind of put them all together. And then after that, we're looking at coming up on a test. All right, so what do you think the word rotate means? Go ahead. Move how?
In clockwise or counterclockwise?
Yeah, that's a good way to say it. You can either move clockwise or counterclockwise. Moving as in turning, all right, spinning. It's kind of funny that they call these rotations because when we were kids, you know how like you guys have different insults when you insult each other? I don't know what all of the current insults are from kid to kid to kid, but one of the ones we had growing up was rotate. Oh, go rotate. I don't understand. I never understood what it meant. And then there was one from, you ever see the TV show Happy Days?
No.
With Fonzie and Richie Cunningham and Joni and Chachi and all those other ones?
The door.
It was a great show. It was really, you guys, I feel so bad for you. You don't even have an understanding of how much society has degraded around you and how evil the world is around you. It really is. And it's so hard for a 12 or 13 or 10 or 11-year-old kid to recognize evil when they see it and to stand up for it. Well, back when I was a kid, it was starting to get a little bad when your parents were kids. But it wasn't anywhere as bad as it is now. Now, what kind of sitcoms do you guys have on TV? Family Guy. Oh yeah, that's a positive influence.
Jesse.
Right? All of these bad things. What we had Happy Days. And in Happy Days, we had Mr. C working hard for the family, Mrs. C being an amazing mom, and then even the rebel guy, Fonzie, was still a good-hearted rebel. And Fonzie would fix everything, and he would go like, hey. And if they really wanted to insult you, they didn't drop curses, no F-bombs or other bombs. What they do is they just go sit on it. I never understood what that meant. But that's what they did. And there was no talk about hanky-panky at all.
Wait, what does that mean?
Boy-girl stuff.
Oh.
They didn't talk about that at all. You know what the only allusion they would make to that was? That they would go to the lake and watch the submarine races.
Wait, what?
Oh my god.
What is that?
Could you ever see submarine races?
No.
That would be the point.
Wait, so. Wait. Can you explain it?
And then one time, Richie Cunningham snuck out of the house to go watch a drag race between 2 cars. And he comes home, and you know his father punished him? Richie Cunningham walks in the house and goes like this. Grounded for life. What does that mean? Grounded for life. So it was a very clean-cut show compared to the shows of today.
But what about the submarine?
Oh my god.
Anyway,
You know what that is?
yeah, he's just, yeah,
I
no,
don't
we're not
know,
going there.
like
If you don't know, all the better. Now, speaking of rotations and happy days, we'll create some happy math days with these rotations. Now, the first thing that's very important to know is Kayla mentioned clockwise and counterclockwise. Now, take a look at the clock up here for a second. Do you see the little red second hand? Rachel, see the little red second hand, and you see how it's going this way? That's clockwise. If it goes the other way, it's counterclockwise. This is a picture of the black triangle turning into the more reddish triangle, and this is a positive rotation. Positive 90 degrees. Counterclockwise is positive, okay? So there's a picture of a 90-degree turn. Is it pretty obvious we're not reflecting there?
Yes.
Okay? Is it pretty obvious we're not dilating because it's not getting bigger? This is what a rotation looks like. Look at this one. It turns. See the rotation there? Okay. A little talk more about counterclockwise and clockwise. If we turn clockwise, we go this way. Counterclockwise, we go that way. Okay? Here's the letter P. A quarter turn. Here's another quarter turn. That makes it a half turn altogether. Another quarter turn makes it 3/4 of a turn. If you do one more turn, which figure will you end up looking like? P. Very good. Okay? Here's another picture of a rotation. We always begin with PQR and we go to the primes. We've done that now a couple of days. And you can see PQR rotating clockwise, turn into the P primes. Okay? Now, let's learn how to rotate on your paper. Everybody mark the point 3, 7. Okay, this is very important that you draw it on the paper because I'm going to show you the easiest way in the world to rotate.
That is so hard.
Yes?
Houdini.
So like put rotations and stuff together now.
You mean multiple rotations? That'll be in a couple of days. Now, ready? This, to me, is the best way I know of to do rotations. Everybody mark your paper? Mark it 3, 7. Now, put your finger right smack in the middle of the graph. Put it right in the middle of the graph. Now, start with your paper facing perfectly up to the top of your desk. Now, I want you to spin it counterclockwise a quarter turn, because a quarter turn is 90 degrees. Spin it a quarter turn.
My paper's like not paper.
So we'll get to that in a minute. Just turn your paper 90 degrees. Now, look, starts here, turn 90 degrees this way. Now, look where this point is. What would the coordinates of this point be now?
I'll smash it. Oh.
What would the new coordinates be?
-7.
-7, comma, 3. So the answer is -7, 3. Done.
Bam.
How'd you get that?
Oh my god.
Daniel.
You take the point, you take the paper, put it right back where it started, put it where it started, turn it 90 degrees, turn, stop, look at the point. What are the coordinates of that point? Look at the point, don't look at me. What are the coordinates of that point?
Mr.
-7, 3. Done.
Smash it.
Okay? Now,
No.
everybody go mark -2, 4. -2, 4. Mark that page. What did I step on? A bead or something.
What?
-2, 4. Everybody mark that point. Now, turn your paper 90 degrees again. Mark -2, 4.
What? No.
Turn your paper 90 degrees. 90 only, not 180. What would be the coordinates of the new point? -4, -2? Let me just check here with Jerry's paper. I can't spin the Eno board, so.
-4.
Okay, here we go. Ready? Here's -2, 4. I spin it 90 degrees. Now I would get -4, -2. So that's my answer. negative 4, negative 2. Okay? Now, everybody mark your paper on negative 1, negative 5. Oh, that's supposed to be green. Turn your paper 90 degrees again. What do you come up with? Positive 5, I think negative 1. Isn't that point below the axis? Right? Here we go. I'm going to turn it 90 degrees. Here's the point. Negative 1, negative 5, turn 90 degrees. I get positive 5, negative 1. So positive 5, negative 1 is the correct answer. Now, those were all rotated by 90 degrees. So in general, if I have a 90-degree rotation of xy, look what's happening. 3, 7, negative 7, 3. What do you think happens to the x? Where does it go? First or second place? It starts off in the first place. Where does it end up? Second place. And the y starts in the second place. What happens to it and where does it end up?
First place.
And it gets negated. So that's my general rule. Now let's go back and do all the points again by 180. Everybody find that point 3, 7. It's the red point on my paper. 3, 7. So you already have it there. Now turn your paper 90, 180. So turn and turn again. So now your paper should be completely upside down.
Oh.
Right? And now, what are the coordinates that you get? Negative 3, negative 7. Good. Take the point negative 2, 4. Rotate it 180 degrees.
184 degrees.
What do we get when we do the 180 degree rotation?
1, 2,
You get
Positive 2.
positive 2,
Negative 1.
negative 4. Good. And now, turn the green point we started with, negative 1, negative 5, turn that 180 degrees.
Negative 1. I mean 1, 5.
Positive 1, 5. Good. So now let's do the rule for 180. XY becomes what? Look what's happening. What?
Negative.
Negative. The x becomes negative.
1.
No,
4.
it's negative x.
Oh, bro.
See, right? The 3 stays to negative 3. And the y becomes what?
Negative.
Negative y. Good. Let's go back to the point again. This time let's turn 270 degrees. Starting where it normally does. How do you get to 270? 1, 2, 3. 90 times 3 is 270. So turn it 270 degrees.
1,
2, 3. Good. And what would the coordinate, I'm going to write them on the side here. What would the coordinate for 270 be? What would it be? Let me take the paper here. Ready? We're doing the point 37 first. Oh, I did 27 on your paper. Oh, you did 27. 37. Let's see. 90, 180, 270. I get positive 7, negative 3, right?
boom.
Positive 7, negative 3. What about the blue point? Haha, my hometown. What about the blue point?
blue point.
Yes, that's where I grew up.
Oh, I go.
Get it next time over?
Yellow. They have that
270 degree turn. Go ahead, do it. You, let me do this.
Positive 4, positive 2.
I don't know about that one.
Positive 4,
Yeah.
negative.
I don't think it's positive 4. Oh, no, wait, yes, it could be because of this one. Very good. All right, negative 2, 4, 90, 180, 270, and I get 4, 2. I got a very important question coming for you guys in a minute.
360.
Now, do the next one, negative 1, negative 5, 270 degrees. 270 degrees.
Negative 5, positive 1.
Does everybody agree with negative 5, positive 1?
Yep.
Okay, now here's the question for you.
Let's go +1.
We did 270 degrees counterclockwise. If I went clockwise, how far would I have to go to get to the same place? 90. In other words, take your paper and instead of going counterclockwise 3 turns, go clockwise 1 turn. Don't you get to the same exact place? Okay? So that is how we work that out. Okay, happy recap. What's the same or different about rotations, dilations, and reflections? Let me give you a specific. Only one of them changes the size of an object. Which is the one that changes the size of an object? Rach? Dilation. Good. Which 2 do not change the size of an object? Hey, look in here. Which 2 do not change the size of an object? Very good. We call that an isometry. We'll talk more about that tomorrow. All right. Don't forget to do a great job on your homework tonight.